So our next talk is called Codeless Machine Learning in R Shiny. It's presented by Stefan Liner, who is a freelance R Shiny developer. He's been working with R since 2017 and has been a freelance R developer for 1 year and a half. Currently, he's developing Shiny applications that automates data manipulation, analysis, visualization, and reporting tasks for several companies, mainly on the pharma healthcare sector. And he has also developed the R package Boost TRQ for scientific publication in cooperation with the University of Passau. And he is also the maintainer of the R package TidyMC on CRAN. This talk will be also recorded, but Stefan is here, so feel free to ask questions on the chat or on our Slack channel. So be ready for the next talk.
Welcome to my talk, Codeless Machine Learning in R Shiny. My name is Stefan Liner, and I'm really happy that I have the opportunity today to present you my Shiny app at ShinyConf. As the name of the talk already suggests, my Shiny app is about automating machine learning with the help of Shiny, so you don't need to have any coding experience, but still can fit your machine learning model. At the very beginning of a machine learning task, usually is a dataset. So also in my Shiny app, you first are asked to either upload your own dataset here or to select an exemplary dataset, which we are going to do. And we select the Titanic dataset, which is really famous for machine learning. And the first thing usually you need to do when you upload your own dataset is to choose whether it's a classification or a regression task. For Titanic dataset, it's a classification task, and more specifically, you want to predict the target variable survived, which means whether a passenger survived the Titanic accident or not. And you want to predict that variable using those feature variables. You also have here directly an overview of your uploaded or selected dataset with the target variable and all the feature variables available. And here you can already see that some variables are not really meaningful, the cabin usually, and also the name and the ticket number usually is not meaningful for predicting this target variable. So we are going to exclude those variables by just removing them from this feature selection here and also the cabin. Then you can see that those also disappear here and are not displayed anymore. What you can also see here is that you have a tab called test data. And in this tab, your data which you want to predict is stored. In this case, the survived information is missing because that's the information you want to predict with your machine learning model. And what we are also going to do is we are going to split our training data, so this part, such that we have 20% of our training data as a holdout set to later use to validate or evaluate our fitted models. And here now we can see, okay, this training data is holdout and we can use it for model validation later on. You can also do some explorative plots with that app. However, I'm not going to dive more into detail here because we have a bit of a time constraint. So I move on to the more exciting part, which is the first thing we have to do in the modeling part is to define our models. That means we first need to choose the algorithms we want to use to predict our data. In this case, I'm going to choose the random forest and the decision tree. Here in this button, you can also define some model parameters of the given models. In this case, it would be the max depth. And the nice thing here is that you also have a auto-generated description to each parameter. So whatever you're going to choose, you have a short description above describing what this parameter is used for in the model. When you have chosen those tuning parameters and you're happy with your choices, you can already train the models here. However, usually you want to tune your model, so I'm not going to train them just yet, but first do a bit of model tuning, which is done in the next tab. In this tab, you first choose your models which you want to tune. I want to tune both of my models I have defined here. And then you can choose the tuning method which should be used. In our case, we're going to use 5-fold cross-validation and evaluate 10 different parameter combinations here. And now we need to choose the variables which should be tuned for those models. For the random forest, I want to tune the M-try ratio and the number of trees. And as you can see here, you get these input fields where you can choose the different ranges of the parameters they should be tuned over. And I'm going to choose from 1% to 30% for the M-try ratio, and the number of trees should vary from 100 to 1000. When I'm happy for my choice, I'm just click here on OK and go on to the decision tree, where I'm going to tune the max depth from 1 to 30 as the default already suggests. And then I'm going to click on tune the models, and the models are going to be tuned automatically. Once the tuning is done, we can see the tuning results below. And I think the most informative result is this table here, which shows all 10 different parameter combination and highlights the combination which performed best according to the measure we chose to be used in the tuning, which is here the classification error. However, you can also choose different measures as you like, based on your use case. And also, after the tuning is done, you can still check how the result would have been for different measures. For example, we can choose here area under the curve, and then also the tuning results are calculated for this specific measure and displayed in this table in just a moment. And then you can also sort this table according to area under the curve and see that in this case, maybe a different parameter combination would have been better. In the next part, we can use our models to predict data. Either you can upload here, once again, a dataset for prediction, or you just use our test data, which we defined in the very first part for prediction. This is what we are going to do now by just clicking on predict. This takes a few seconds, then it should be done. And then you can see here, once again, you can choose different measures to evaluate your predictions. And you can see that for the classification error, actually the decision tree and the random forest achieve the same result. But for example, for area under the curve, the random forest achieves a better result than the decision tree. In this table now, you see once again your prediction, so which you actually predicted which outcome, then also the true outcome for those cases, and you also see a probability which is given for the class of which is predicted. This is now for the decision tree, and we can also change once again here to the random forest, and this table adapts to the results of the random forest. What you can also do is you can change the threshold here. So for example, now yes is predicted when the probability of yes is greater than 0.5 and no otherwise, but you could also adapt this here, but what we are not going to do now, but it's anyways possible. And below you find more plots which just visualize your predictions and also the classes of your uploaded test data set or the test data which you use to predict your classes for. Now we come to the last part of the app, which is about deployment. So once you have fitted your model and you're happy with your model and you would like to use it in production, you need to somehow get your model out of this app and in production. And usually models are used in production using an API, and that's what you can do here. By just clicking on this button here, you deploy your model as an API to AWS SageMaker. However, this will take a few minutes, so we will be back once this is done. Once the model deployment was successful, you have an overview here. Here you see which model was deployed. It's called Admin Titanic Ranger in this case. And here you can see the version and when it was created. So it was created by today, and the version is this one. So now when you do some changes on your model, update it with new data or update some parameters and deploy it again, then it gets a new version and you can track your versions like this over time. Now we head over to AWS and we see here that an endpoint was created for our model. And now we test this API endpoint with some test data. I have prepared here some JSON test data, which contains the variables. And for this test data, we now do a prediction. We send this API, and the response we get from this API is for those two observations a prediction, which for survived, which in both cases is no. So we can see this API endpoint works perfectly, and we can use it like this in production. This is now also the end of my talk, and I want to thank you very much for your attention, and I hope you found it interesting and maybe found something useful for your own projects, and I hope you have a good time at the ShinyConf.
Thank you very much, Stefan. And yes, there's one question that would be, once we have deployed a model after doing our test and choosing the variables and every parameter that we want, the way to access and predict is through the AWS, or are you planning also to maybe create a feature that from Shiny we can access and send easily those new data to make predictions?
So until now, it's through AWS or within the Shiny app. So within the Shiny app, you also have the option to upload a new dataset where you can run your predictions on. But if you want to do predictions outside of the Shiny app, you need to head to AWS, to AWS SageMaker to make predictions. But there would be a way to make it generally the API in general available to any other code sources, if it's your Python script on your local computer or not. But then you would need to wrap an API gateway of AWS around this AWS SageMaker API, and that would be a way to do it. But this is not implemented yet, but it would be doable in general.
Great. So thank you very much again, Stefan.